Hello everybody, nice to meet you. My name is Dario Tranchitella, and I'm here with Marcello, our community manager, and this is a special community call for the Kubernetes Multi-tenancy meetup group. And we are really happy to have here Dolis and Jim from Nirmata, the company behind Kyverno. So a brief overview of our meetups. We are a group of people that we love Kubernetes, and especially we are trying to evangelize regarding the multi-tenancy area of Kubernetes. You know, with Kubernetes, you can spawn multiple clusters, you can use namespaces, you can use tenants, you can use whatever you want. So our goal is to create a community around the best practices and all the caveats to use at your best the tools that the open source community is providing. And today we are going to get a nice introduction by the Nirmata people, and we are really happy because honestly, I really love Kyverno because Kyverno is the true Kubernetes native policy engine because you're using CRDs to manage all the policies. You don't need to write a specific domain-specific language. So it's something that you just need to learn YAML. We all know that sometimes YAML are so silly, but it's really convenient because we are doing Kubernetes stuff, so we know how to indent YAML properly. Anyway, jokes apart, because you know I do a lot of jokes, I think that we can pass the microphone to Dolis and Jim. So mates, please introduce yourself so people can know you, and you can start also sharing your screen with the presentation. I'll mute myself. Go on.
Thank you, Dario. Thanks, Marcello, for having us. Real pleasure to be here presenting to the community, and thanks everyone for joining. So just, in terms of what we will cover today, and then we'll do some brief introductions. So we will, like Dario mentioned, we'll talk about Kyverno and policy management. But before we understand, how Kyverno works, I think it's also important to know why policies, right? Why do we even care about policies? Why should we have them in our cluster, and what can they do for us? And then we'll dive in a little bit deeper into Kyverno. We'll look hands-on at how Kyverno can potentially help with some multi-tenancy scenarios when you're sharing clusters for different applications, different teams. And we'll keep it very, interactive. So we'll do a lot of, keyboard demos as well as show how policies are applied. So you get a good understanding of how these could work. So just quick introductions. I'll let Dolis introduce herself, and then I'll introduce myself.
Sure. Thank you, Jim. My name is Dolis. I'm a customer success engineer in Nirmata. So I have completed some certificates, but on the other side, I'm still a learner. And thank you for your time today. And it is great to meet you today.
Thanks, Dolis. And I'm Jim Bugwadia, a co-founder at Nirmata. I also, co-created Kyverno as we were looking at, bringing policies into Kubernetes, and Dario already gave us a really good plug. So we'll talk a little bit about what it means to be Kubernetes native. I also do some work in the Kubernetes community, in the policy working group, as well as the multi-tenancy working groups. So without further ado, just, getting into policies, right? And myself, I'm a software developer by background, right? And to me, if somebody said, hey, you need to use policies, I don't think I would perceive that initially as a good thing, right? Because it's like, okay, what are these policies? And oh my God, that sounds like bureaucracy, and I have to now do other things, right? But here, what we're talking about is, if you think of, in Kubernetes, there's several different roles that need to touch a cluster, right? There's developers who want to deploy and operate apps. There's security teams who, of course, want to make sure those workloads and the clusters are secure. And there's the operations teams providing the shared services, the clusters, everything else required to make Kubernetes work, right? And policies in Kubernetes, and really kind of making them, and today we have this thing about making everything as code. So making policies digital and bringing them into Kubernetes as a Kubernetes object really changes the game, right? And it allows developers, security teams, operations teams to agree to say, hey, this is how we're going to work, and this is how we want to do things in our organization, whether it's for business needs, compliance needs, security, of course, best practices, things like that. And then it eases the burden on each of these individual roles or new people coming into Kubernetes. I don't have to understand, okay, what are all the nitty-gritty details required in each pod spec. I just have to focus on my piece, and some of these other pieces are secured, right? So you're providing the guardrails. You're not creating more barriers or more gates for each of these roles to efficiently do their jobs, right? And what it really means is, again, if you're looking at these clusters and even in a small scale, the separation of concerns becomes very important. Because in Kubernetes, you have these YAML declarations. And like Dario said, we may either love YAML or hate YAML, but it's something we have to deal with in Kubernetes at this point, right? So you have gobs and gobs of these YAML definitions. If you get a Helm chart, maybe there's thousands of lines of YAMLs in it. How do you make sure that your organization security needs are protected? How do you make sure that the best practices are followed, like for even things like health checks and probes, and making sure that each pod has a security context, right? And how do you automate mundane things? Because policies are not just about blocking things or enforcing things or showing kind of violations, but they can also be used to automate, right? And in IT, like in enterprise IT, that is how policies typically get used, global policies for automation. So why can't we do that for Kubernetes itself? And like when a namespace gets created, automatically create fine-grained permissions, right? You shouldn't have to go and do that manually, or there shouldn't be any risk of it not happening, things like that, right? So that's what when we think about policies for Kubernetes, those are the top type of things that come to mind. And I love this, tweet. This is from a little while ago, but it's still very relevant, from one of our community members, someone who's very active in the Kubernetes space. You might have seen his Twitter handle, and some of his posts and what he shares. But and from his point of view, and I completely agree with this, is if you're not running with policies, there's disasters waiting to happen, right? It's not a matter of if, it's a matter of when. So it's always best to start with policies up front and make sure that you're properly protected and you have the right things in mind. So that's kind of the why policies part of it. Now, if we want to talk about, okay, why Kyverno, right? And what does it do differently than other policy engines like OPA, Gatekeeper, and there's new ones like Kubewarden, and there's JS policy and others, right? So with Kyverno, the approach we took is to say, look, we're trying to solve a problem for Kubernetes. We're not creating a general purpose policy engine which can work outside of Kubernetes. We're not trying to define a new language, but we want to do things how Kubernetes works. So we wanted to make policies extremely easy for anybody who knows Kubernetes. They should be able to write Kyverno policies. There's no language to learn. It follows the same kind of declarative YAML. In fact, a pod policy will look almost exactly like a pod, or it's a fragment of how a pod declaration looks. So if you're familiar with what a deployment looks like or a pod looks like, which we all, of course, have to learn if you're using Kubernetes, writing a Kyverno policy doesn't have much more of a learning curve than that, right? The other thing we saw with other existing tools, it wasn't really easy to get policy results. And what's the point of policies if I don't know what they're doing and how they're, what should I do, right? As a developer, I deploy my pod, tell me what I need to fix or improve or do to comply with the policies. So making those policy results easy to see and easy to get was also very important. And then being able to cover not just like I was mentioning, the validation and the enforcement part of it, but also to be able to mutate, generate resources on the fly based on different triggers. That was a key use case, right? Of course, in Kubernetes today, you might almost 50% of your resources might be custom resources because Kubernetes is so extensible, and there are so many great frameworks like other than Kyverno, or like even some of the tools that Dario mentioned, like which we are using for multi-tenancy, or other tools like even Argo CD and Flux and others, right? So being able to even manage policies for all of these, including frameworks like Service Mesh, or if you're using other tools, all of that, right? But custom resources. And then, and by the way Kyverno does that, again, to explain why this matters and what we're calling out, is Kyverno looks up the Open API v3 schema of all of these resources and understands how these resources are structured for the version you're running and applies policies accordingly, right? So it's not just, okay, Kyverno knows how to process JSON or YAML, but it does introspect the schema, and that provides it greater intelligence when it comes to processing Kubernetes policies for custom resources itself. And then there's other best practices like, there's owner references and pod controllers and labels and selectors. Kyverno is aware of all of these, and actually, even like with the recent 1.8 release, Kyverno is now aware of pod security admission, right? So it can understand how pod security admission works. In fact, it reuses the same library that Kubernetes uses underneath to help with some pod security policies, which you can't otherwise do with a general purpose policy engine, right? So now, of course, the value in using a general purpose engine is if you have use cases, you're trying to write policies for cloud or policies for some other thing, great. Then, maybe using Rego and using OPA makes a lot of sense. But if you're trying to solve a problem for Kubernetes, Kyverno provides, at least in our opinion, a much better experience and solves a much broader set of problems, right? And if you kind of want to see a deeper dive, some of you may already know Viktor. Viktor's currently at Upbound, the company behind Crossplane, but he's got a very popular YouTube channel where he talks about a lot of different technologies, and he did a very good deep dive on Kyverno versus OPA for Kubernetes, of course. And the video's out there, so feel free to look it up and see, get his thoughts on where to use what. All right, so moving into the features, and then Dolis will kind of dive into the deeper into what exactly a policy looks like, and we'll look at installing Kyverno and getting started with that. But just covering the features very quickly, the top, why you would want to choose Kyverno versus something else again. So this no code aspect, and of course you could argue that YAML is code, but at least it's sticking with the Kubernetes way of doing it, covering security and automation, and then integrated, kind of works with kubectl, Kustomize, Helm. All of this just becomes natural because you're not using any other language on top of this, right? So that's a quick, kind of thing on, again, the features and why folks would choose Kyverno. How this works within your cluster, just to quickly explain. So Kyverno can be operated in 3 different modes. By default, when you install Kyverno, it registers as an admission controller, which means every API request going through Kubernetes, and of course, everything in Kubernetes flows through the API server, Kyverno can apply either mutating or validating checks to that. And based on your configured policies, Kyverno automatically configures the webhooks for receiving the request for those policies. And then internally, it builds a policy cache from which it can apply these type of, mutating or validating changes, right? There are, for the generate policies, the trigger is still the webhook. So when something changes, the webhook gets invoked. And in the background, it will then generate the resources once that resource, like the trigger resource, is created. Example of that is when a namespace is created, you might want to create a default network policy or something to that effect, right? And whenever a policy is changed, the policy controller watches that and then reapplies all the rules to the existing resources. And it's also responsible for running background scans, right? So that's a high-level view of how Kyverno works as an admission controller. It also, periodically you can configure it to scan all your resources, and you can also run it in a CLI mode outside of your cluster, where you can just apply Kyverno to YAML manifest, or you can point to a cluster without installing Kyverno in your cluster and also scan that cluster for policies. So lots of flexibility through the CLI in terms of how you want to check. So that's probably one of the easiest way to get started. Download the CLI and just scan your cluster, like for pod security and other policies. This is, I won't go into details here, but this is a bunch of, stuff that Kyverno will install in your namespace. You'll, when Dolis kind of runs us through a quick demo on this, we'll see what some of this looks like, but there'll be, deployment services, some config maps and other things, and a bunch of CRDs for policies, policy reports, things like that. So just last thing I'll cover in this section is, some of the top use cases. So as a lot of you know, pod security, policies are deprecated in Kubernetes. Officially, they have been removed, and pod security admission is now the new replacement for it. But pod security admission, it works at the namespace level, which is, a good starting point. But very often you are going to require fine-grained checks, which Kyverno or other policy engines can provide. So we have a new, pod security policy, which came in 1.8, which you can leverage to, use Kyverno for pod security. Highly recommend looking at that. If you're running Kubernetes, you do need pod security. It's not an optional thing. You should enable pod security admission, and you should configure a policy engine on top for finer grained controls and checks, right? So definitely look at that. Best practices on workloads, on different things. There's over like 200 policies available in our community, in our policy library. So do take a look at that. Getting rid of misconfigurations or preventing them. Multi-tenancy, which we'll focus on today. And then container image signing, verification. With our latest release, we also have YAML signing capabilities, which is a very interesting use case. Because it lets you do things like tamper detection on key critical resources, etc. So some interesting things over there also. But for the rest of this session, we'll mostly focus on multi-tenancy, but just wanted to quickly give a view of some of the other the features and things available. So with that, let me hand off to Dolis, and she will kind of quickly show us what a Kyverno policy looks like. Just the structure of it, and then dive into some demos itself.
Sure. Thank you, Jim. I hope you can see my screen. So I'm just going to adjust my couple of things over here. Perfect. So, okay, so we are going to look at Kyverno policy, and I'm going to give you some demos of how you can install Kyverno and maybe what a policy looks like. So a Kyverno policy is, this is a basic structure of what a Kyverno policy looks, and a Kyverno policy generally have a collection of rules. So you can see there are one rule over here, but a policy can have more than one rule. And whenever we receive an API request to your cluster, usually we validate it with a set of these rules. Now, a policy also have some kind of clauses. So you can see there are different clauses. For example, there is a match clause over here, there's an exclude, and there's different mutate, verify, validate kind of clauses as well. So these clauses are really useful if you want to match certain Kubernetes resources. For example, over here, you have a lot of Kubernetes resources, you can match this, and this is quite flexible. So you can create your own policies. If not, you want to create your own policies. We have in the website, we have almost like, I have to show you, we had more than one. We have 191 policies, so you can bring up a policy and you can customize it. So this is basically how it looks. And there are some, I'm going to show you how does a policy look like. So this is a normal, simple validate policies, and you'll see that there is one rule over here. It has a match clause, which is matching through a particular pod in this case, and then there is some validate rules. I'm going to talk more about a policy, and also I'll demo a couple of policies. But before that, I want to give you a quick demo, as Jim was saying, that why we require pod security policy. It's a must. But I want to talk about what does a Kubernetes cluster look like, and what is the security concerns that he was talking about. What does it look like, right? So I want to just show you what it looks like. So this is, I'll introduce what I have right now over here. So I have a general kind cluster. It's a one node cluster, and let's see if I have any policies. So I don't have any policies over here. This is a default cluster created by using kind. Now I can deploy something, and I'm just going to show you what I'm going to do. So I have something called as bad pod. Now the reason it's called a bad pod is because it has some configurations which is open. Now I will be using something like everything allowed, and if you'll see that there is a picture which says that doors for everything is open for me. So I can have privileged, I have host process, I have access to host path and all these things. So if I have to show you what a deployment looks like, so this is a deployment, and this is a simple container. There is one container, two replica deployment, and if it has all settings true over here, and then it is running as a privileged is equal to true. So what I can do is I can run this bad pod, and I can show you what it looks like. So I'm just going to grab this command from here, and I'm going to go to my terminal, and I'm running this bad pod. And it is configured and it is created. Now, once this is up, I will just show you that using a single command, I can actually get access to a lot of things. And over here, if you'll see that I just exec into this pod and I got access to the host, and now I am a root access to my kind cluster. If I have to do who am I, it will tell me that I am root. And if I'm a little bit aware of where my certificates are, or if I have a little knowledge of how Kubernetes works in general, I can easily go to the path and I can get access to all these certificates. I can get access to the database. I now know that what is this cluster and how it was created, because I can see a kind folder over here, right? So it did not actually block anything. I do not require a lot of permission. Just one thing I require was to deploy this bad pod, which I'm calling it. And I just deployed this, and it made me my way to get into the host, right? So this is what it looks like ideally. And that's what we require pod security, the entire concept around why we require pod security policy and why Kubernetes is insecure by default is something that we have demonstrated. Now I'm going to show you how we can deploy Kyverno and how it looks like once we have pod security policies up. So checking another screen, I have one more terminal. I have this terminal where I don't have Kyverno deployed, and I'm just going to show you what namespace it has, and it doesn't have it doesn't have any Kyverno namespace. So you can deploy Kyverno using a simple command. So you can use this single command, and this is my favorite command because this is just a single command. But if you're a Helm person, you can use Helm. Helm is always little. I always predict what is coming along Helm, so I generally prefer this command. I can see the YAML, so I'm going to use this one. But if you're a Helm person, you can use a couple of commands over here, and you can deploy it using Helm. Now, what I'm going to do is I'm just going to run it. Hit enter, and if I'm not sure whether you're able to see this, but I think this font is good. Okay, so yes, I think this deployed a lot of resources over here. If you want to take a look of what exactly it's deploying, you can go into this link, which is there on the website, and you can look at all these resources. But this one command is sufficient to deploy Kyverno. And if everything goes well, I think Kyverno should be here. Okay. So it's going to take a little bit of time, and then it's going to initialize and the pod is going to come up. So I think I'm going to just close this, and I have already Kyverno deployed here. So I'm going to just go with that. But before that, I just want to show you whether it's up or not. Okay, I was in the okay. So here I have my Kyverno up and the Kyverno is running. So I have first step, which is completed. That is, I have my Kyverno up. Now let's see and deploy some policies. So I have a customized command. Using this command, what I can do is I can deploy these policies. So what this command is doing is it's taking my policies from this GitHub repository and it's building these policies and it's applying this. Now all these policies is visible over here. So you have, you can take these policies. I'm basically deploying all these policies, but what you can do is you can take these policies and put it in your private repo and you can pull it from there. But going back, so hitting enter, and it'll just gonna give me, okay, so it's gonna give me a list and everything is created. Perfect. So I'm going to check the policy status, and the way you can do it is kubectl get cpol. Cpol stand for cluster policy, and you'll see a couple of them are coming in ready. The status is increasing. Maybe I'll not wait for everything to come to ready state, but you'll see the policies are already applied and they are in enforce mode. So basically a policy have two mode. There's one is the enforce mode, other is the audit mode. In enforce mode, it's going to block the creation of your resources which does not match the condition. And in audit mode, it's going to audit it for you and going to show you that, hey, listen, this is something that is wrong. You need to work on it, but I'm still allowing it, right? So that's the two mode. I have changed it to enforce just so that I can show you that when I'll try the bad pod, it's going to block it for now. So I'm going to go back, and just as a user, I'm going to take my bad pod, trying to do some things over here, and I'm going to apply this, and I'm going to hit enter. And there you go. So this time you saw that there was no pod created. Actually, the policy blocked it, and it has some messages saying that this container must drop all capabilities. It has access to host PID, and it has access to volumes, and this is not a good pod, so it's not going to allow it. So that is one way you can actually block and make sure that your cluster is secure. Also, there is one more interesting thing I can show you is whatever, like if I have to check what namespace I have some namespaces, and there are some pods running on this namespace. So since I have deployed the policies, I want to make sure what is the audit report of this namespace. So what you can do is Kyverno will scan this and it will create an audit report for you. So you can deploy this command and you can see that these are some policy reports that are being generated for you. So you'll see that in my default namespace, I have some pass, I have some failed, and you'll get a report of this. And if you want to describe specifically some of the policy report, you can just run this command and it will give you a description of what's failing, what is the deployment, why it is failing, what is the message, and every detail. So using this audit report, what you can do is you can see what exactly is failing and maybe go back and just configure it properly and make your cluster more secure. Under one more thing I would like to show you is the CLI thing. So if you don't have Kyverno installed on your cluster, and if you just want to use Kyverno CLI in your CI/CD pipeline, as Jim was suggesting, that you can actually do an audit of your cluster runtime, you can actually use a command, and I'm just going to copy that. So this is again the same customized command, and I'm taking the policies from the GitHub and I'm building it, and I'm using a Kyverno CLI over here. This becomes really handy if you don't have Kyverno installed or running in your cluster, and you can add this command into your CI/CD pipeline, and it's going to do what is going to apply it for the cluster, and you can change your namespace and get an audit report of what is going wrong. And you see a big list over here, right? So you'll see what is happening on this. What is the spot? It tells me that, hey, listen, this everything allowed is bad. I don't like it. I have a lot of policy violations, right? So yeah, I think we covered that. I think it was hopefully that gives you an idea that how you can deploy Kyverno and bring your cluster, secure your cluster in a couple of commands using pod security policies. Now, we are going to, I think Jim is going to talk about a little bit about multi-tenancy, and meanwhile, I'll just bring my screen up and I'm going to prep for the other demo, which I'm going to start for the multi-tenancy. Over to you, Jim.
Thank you, Dolis. Yeah, so you kind of saw just how easy it was, with those few commands to be able to install Kyverno, get it up and running. And also, installed, we have pod security policies, we have other sample policies for best practices. So to quickly get started, right? So, and with a few, basically in under a minute or so, you can go from zero security to pretty good security with Kyverno, right? So, but now let's switch to multi-tenancy and what Kyverno can do for, and by the way, regardless of what you're doing for multi-tenancy, I think it's just worth re-emphasizing that definitely, use pod security and, also check out pod security admission, enable that by default, and then, kind of then start leveraging Kyverno for other finer grained checks and other things. So when you talk about multi-tenancy, I think, and this was a blog post we did from the multi-tenancy working group a while ago. But there's three or so main models that come to mind, right? The most common way is, of course, you're sharing a cluster for different teams, for different apps, and you're creating namespaces. Maybe you want self-service of namespaces, and you want secure namespaces, right? So the blast radius, if somebody does run a bad pod like Dolis did and gets into your namespace, you don't want them to, be able to get access to other things. Of course, in that example, they were able to get access to the host, but even that, you want to prevent from happening, especially in a multi-tenant environment. Clusters as a service is where you're spinning up either, like this is mostly with cloud providers and managed services, but you're bringing up clusters for each team, for each app. And then finally, control planes, as a service or virtual clusters is where you would be, sharing the underlying, compute resources, but you're creating different control planes, one for each tenant, right? But for all of these, the thing that's important to look at, and by the way, also from the multi-tenancy working group just recently, about a month or two ago, in the Kubernetes talks, now there's a chapter on multi-tenancy, which we're very excited to kind of push that forward and make that available. And it talks about isolation at 3 levels, right? So there's control plane, data plane, and then there's other like fairness and other things that you have to think about. So going very quickly through each one, and do look at, you can go through the docs and look at that in detail. But when we're talking about control plane isolation, the building block for that is namespaces. Kubernetes, a lot of the Kubernetes constructs build on top of namespaces, like network policies and, resource quotas, as well as, roles, etc. So starting with that is very important, and micro-segmenting as much as possible for your namespaces. Having proper access control in RBAC, having proper quotas, and all of this, what Dolis will show us very soon, is how you can do that with policies. But these are the 3 things you would think about first at the control plane level. On the data plane, obviously, you want to make sure that network policies are running, so traffic across your pods and your namespaces is properly controlled. On the storage side, you want to make sure that you're using the right settings for your storage classes, etc. So one tenant's volumes are not visible or cannot be claimed by some other tenant. You may want to consider things like container sandboxing, right, with gvisor. You also can do node isolation for some tenants if you want to put their workloads on different compute resources altogether. And then finally, you want to kind of think through the fairness, the priority, because you don't want one noisy neighbor to impact others. You want to use the constructs of quality of service, as well as some of the other priority scheduling and features available. You also have to think about DNS and whether you're running separate DNS services for each tenant, whether you're sharing one. And then if you have any other shared services operators, how are those being shared, right? Do you create like a monitoring instance per tenant, or do you share those, right? So several things, and the document goes through these in detail, but what we'll look at next is just how you can now use policies to get you going and to address a lot of these factors that we just talked about.
Cool. So I'm just going to share my screen again, and I'm going to bring up my terminal. Though I have in the background, I have the control plane isolation, because I think let's start with the demo for control plane isolation. So as Jim has already said, control plane isolation has namespace, then you have access control and quota. What does this mean is that every namespace should have a quota. It should have a quota, it should have a limit range, and then owners of that namespace should be able to use the namespace. So there should be granular access control for the namespace level. So I have certain policies that can help you achieve this, and I'm going to just bring it up. So, okay, so I have 2 policies over here, which is going to make sure that every namespace, whichever is created, has a quota created. And if we look at what does the policy do, this is generally a generate policy. Now let's go through this. Let's take a little bit of time and understand what does policy look like and what are the rules and conditions look like. So basic couple of lines are just the cluster policy, it's the name, and then you have a rule section over here. Background is false, you can make it true if you want to really, this is really helpful if you want to start a validate policy where you want to do a background check of all the resources that are running in the past, like pre-existing resources in the cluster. And then there is a rule block. So we had discussed about that every policy can have one rule and one or more rules, and this policy have more than one rule. So there is a rule section over here, and it has a generate clause over here. So this is one rule which I'm just selecting. And then we also have another rule over here, which is looking for another kind of, which is having another logic and looking for some other resources. So in particularly in a rule section, you will see that it has a name, then it's scanning for resources. So it's scanning for every namespace. Now you can change this to pod, you can change this to any Kubernetes resources which you want to. In this policy, it's going for namespace, and then it's looking for a selector in this namespace. So it's going to check for the label for this namespace. If the namespace has a label small, it's going to generate a limit range for this. So it's going to create a small limit range. You can again change it, customize it, sky's the limit. It's entirely up to you what you want to achieve. And then the other rule says that if the namespace has a medium label, it's going to create a limit range as per the medium quota. And then if the limit range, if the namespace has a large, it's going to create a larger limit range. The same for the quota. I have a policy that's going to create a quota. Similar logic, it's a generate policy. I have a rule over here. It's going to do the same thing, but over here, it's not going to create a limit range. Moreover, it's going to create a quota for me. So you'll say it's generating a resource quota and not a limit range. So I have three rules in this policy. I have 3 rules in this policy. Now, most of the time I'll be wondering that what if I create a namespace with no label? That will be allowed, right? So it's going to violate my multi-tenancy, all I'm trying to achieve using multi-tenancy. So I have another policy that's going to check for your labels. So this is a policy that is a validate policy. So what it's going to do is it's going to check the namespaces, and it's going to make sure that your namespace has a label. So in the message, and whenever, so you also have a message field in the policy, and this message field is mostly whenever your pod gets violated or blocked, this is something that your user will see on the screen. Totally customizable. You can make it more descriptive just to make sure that you're adding more description and the user can see why the resource is blocked. But in this policy, you see that if a user is going to come in and have a namespace without a label, it will find a message saying that the namespace must have a label type with a value small, medium, and large. So specifically, it's telling you that you should have a label, or else I'm not going to create any namespace for you. So what it will do is it's not only validating your namespace, but also whenever your namespace is creating, it's generating some best resources like quota and limit range according to what we have seen in the multi-tenancy. Now, what I'm going to do is I'm just going to apply it and show you how does that work. So just checking which folder I am in. kubectl create-f, maybe I can apply validate one. So, okay, it does not like that. Let's see. I did some changes in the message, so it did not like that, I think. Let me change it very quickly. I remember I added some of the messages and it's not liking the annotations, maybe. Okay. Now this should work. Okay. So it has created this. Now I'm going to just apply my quota one. So add limit range, and then I'm going to add the quota one as well. So I have the quotas, I have the policies for my limit range, and I have one for my namespace. Perfect. So I'm going to just quickly check what is the status of the policy. Everything is in true, ready, perfect. Now action time. So I'm going to come and let's see if I can create a namespace with no label. So if I just do create namespace $, it is going to tell me that it doesn't like it, and it is going to tell me that it should have something, a value small, medium, large. Okay. Perfect. So if I have a namespace over here and it has a small label. So let's try creating this namespace and see if my quota are actually generated. So if I try this, I see that my namespace is created. Now I have to just checking this. I'll see that my quota is created over here, right? So it has actually picked the namespace label, and it has assigned a quota small for that. Similarly, let's see if what comes under limit range. So yeah, I think a limit range is also created and a small limit range is assigned. So what it does is that it is checking for my labels. That is, I have a small label in my namespace, and it's creating a small quota, and it's creating a limit range for that. If I change this label to medium, maybe it is going to create a medium quota and a medium limit range for this. So this is going to make sure that all your namespace has a resource quota, and your cluster utilization is all your resources are being utilized properly by your applications, and one application doesn't end up utilizing all your cluster resources. So that's one. The other one that we had was that, going back to just so that we know. So other one we had was for the access control. So you want to make sure that whoever is the admin, like we want to make sure that we provide granular access to the users, and a user is able to access its own namespace and doesn't have access to another namespace. So for that, I have another policy. I'm going to just bring it up, and this is an access control policy. Again, you will be a little familiar about what does the syntax look, because it's a generate policy again. So you'll see a different same kind of blocks and sections, but a different logic and a concept. Let's go quickly and check what does this policy do. So these are again same thing, but in the rules you'll see that it is again working with the namespace. It's going to exclude the cluster admin. It's just going to work with the users and going to exclude this role. And what it's going to generate once a namespace is created is it's going to generate your cluster role. So it's going to on the real time, it's going to take the metadata name from the namespace, and it's going to create a cluster role for you, and it's going to create all these actions resources. Similarly, it's going to create a cluster role binding and all these granular access we talk about in Kubernetes language that we require role bindings and all this. It's going to do the entire setup for you and for the users, just to make sure your granular access management is on point. So we have seen the policy, and I'm just going to run a clear command. I'm just searching my policy. Here it is. You do a lot of demos. You just search where are my files. I'm going to apply this policy, which we have recently seen, and this is applied. I love doing cpol and just checking whether it's true and it's enabled. Okay. Now what I'm going to do is I am going to see whether I'm going to try creating a namespace, right? Namespace as Nancy. So I'm going to try creating a namespace as Nancy. Okay, so, okay. So our policy, which we had that the namespace is should have a label is still under 4. So that's the reason it's blocking that. So I'm going to just apply it again. Okay. So I've created a namespace as Nancy, and what I'm going to do is I'm going to create a namespace as Ned. Okay. So what I have over here is I have a policy. I have 2 namespaces. I have one namespace as Nancy, which Nancy has created, and I have one namespace as Ned, which is Ned, and both the person is me here, but roles. So let's see if Nancy is able to see the namespace as Nancy has created. I'm going to do something like this. -o YAML and as Nancy. Okay, so Nancy is able to see her namespace and it looks good. Now let's see if Ned is able to see that. And if I click on Ned, it's going to see that Ned is not able to see the namespace. So it's going to be forbidden for Ned. And same, let's check if Ned is able to see his own namespace, right? So if I go here, Ned is able to see the namespace, but if Nancy is able to, Nancy is not able to, right? So this way you can make sure that a user or a developer who should have access to its own namespace actually have access to only his namespace, and he has granular access and he doesn't have access to other namespace. So that was about granular access control. Now I'm going to delete that policy because what happens is it's going to just be in between other policies logic. So, okay, I've cleaned it up. Now going back to the control plane isolation, we have covered the couple of examples, a namespace, access control, and quotas. Now coming back to my favorite section, which is data plane isolations. So there are a lot of, Jim has already explained it, so I'm not going to explain it again, but I'm going to just quickly tell you what we can do. So there are some terms like network policy. So what is recommended as Kubernetes is every every namespace should have a network policy. So whenever a namespace is created, there should be a network policy as deny all, just to make sure that all the traffic of your pod are into that namespace and it doesn't go out of the namespace. Now, this can be achieved using a policy. Again, gonna bring it up. And this is a network policy. Add a network policy piece. So you can see over here, the thing is same, and it's again a generate network policy. It's generating a network policy, and it's going to look for namespace. So anytime my namespace is getting created, it's going to create a network policy for me. So let's apply this and let's see how it works. So I'm going to apply network policy. There you go. Okay, so I have one, which is the network policy. And what I'm going to do is I'm going to quickly create a namespace. It says already exists. Let's see $1. I have a lot of numbers. So I have created a namespace called $1. And if I have to check for network policy, you'll see that a network policy is already created, right? So this policy will help you to automate these kind of use cases where you're just creating a namespace, nothing else, and it's going to make sure that every namespace has a network policy for you, just to make sure your pod traffic is not going out of the namespace and you are achieving a multi-tenancy using this policy. Now, going ahead, another section for the multi-tenancy was the storage class in PVC. So according to best practices, a storage class should have reclaim policy as delete, so that your PVC cannot be reused across all the namespace. So how do you do that? By the help of a policy. So my favorite screen, I'm going to bring it up, and this is one more policy I have. Now, this is a similar structure. So it has a rule over here. This time it's checking for storage class. We had a lot of namespace sections over here. So a little different. It's checking for a storage class, and it's going to validate, and it's going to say that your storage class should have at least a reclaim policy as delete. Now, another way you can do it is you can also create a mutate policy over here. So there are a lot of use cases which you can play around with. So you can create a mutate policy where every storage class you create, it mutates with reclaim policy as delete, something like that, right? Now I'm going to show you validate one, but yes, of course, there are ways you can do that. So again, the search goes. And okay, so I have a validate reclaim.yaml. This is my policy. I'm going to apply it over here. Applied. Okay. So I have a storage class example, and if you'll see, the storage class is delete. Now let me check if I have any storage class available. I have one. Let me delete this. Okay. And let me just change that storage class, maybe reclaim policy to retain, and show you whether does it validates it or not, right? Okay, perfecto. So kubectl, I'm now applying my storage class, and it will tell me that it is not allowing the storage class because PVC should have reclaim policy at delete. So it gives me a clear indication and a message that, hey, listen, you have to change your PVC reclaim policy. So I'm going to go back as a user. I look at the message. I go back. I change it to whatever Kyverno suggests me to do. And I'm going to change it to delete. Okay. Gonna save this. Okay. Now let's try using it and see. So now it's going to go through and it's going to get created, right? So this was a validate policy, and we made sure that the storage in terms of multi-tenancy for our data plane isolation, our storage class is having the recommended standards as per Kubernetes. Now, the other section is, which is the favorite section, is sandboxing and node isolation. We are running out of time, so I'll quickly show maybe the node isolation piece. I have some policies which I have over here, but maybe I can put it in the channel. I can put it a link and you can try it over here. But let's quickly cover if I can cover the node isolation. And okay. So going back to the node isolation. So what does node isolation mean is that what you can do is you can you can dedicate a set of nodes to running pods for a particular tenant. For example, you have a tenant XYZ, which is a paid tenant. So you want to make sure that paid tenant has a priority class and it is dedicated to a particular node. It just makes sure that commingling of this tenant pod is prohibited, right? So now you have a dedicated node, which has a dedicated pod, which are been running on that node. So what you do is, first step is you just taint your node. So I'm going to taint my node with tenant XYZ, and then I have a pod over here. But before that, I have a policy created for this. So if I have to show you, so I have a policy called add toleration. So what this policy is, and this is a mutate policy. So it's, we looked at generate, we looked at validate. Now this is a mutate policy. So what's going to do is it's going to look for your add toleration, and it's going to look for your pod, and it's going to real time add the toleration for your pod with the help of the label. So I'm going to just apply this policy. Okay, and I have a pod YAML over here. So if I CAD it, I can show you what I'm running. So this is my pod, and it has a label which has the tenant XYZ. So this is my tenant pod. I want to make sure that it is running on a dedicated node, which I've already tainted. So what I'm going to do is, if I try run nginx with this image, and if I do kubectl get nginx, the pod is not going to run because my node is tainted, right? Oh, sorry, I'm just running a little. So you'll see that my nginx is in pending state, and since the node is tainted, it's not going to go through. But if I apply my pod, you'll see that it is not going to even go by that, but it's going to also start running, right? And if I have to show you, I can show you really quickly, just one command over here, that it will have a taint automatically appended on this. And here you go. So you have automatically a toleration with the help of the policy. So you don't have to do anything over here. Now, this was about node isolation. I have one more for the API priority class, but maybe I can just show you the policy. We are running out of time, so I'll just show you the policy, what we can do. So this is a policy for my priority class, and what I have done is, for the same pod, like the pod which is having a label tenant XYZ, once I apply the policy, what is going to make sure is it is appending a priority class name paid for me. And if I have to show you, I have some priority class already here. So I have a paid priority class, I have a free priority class. So what I'm doing is I'm just adding a label to my pod saying that this is tenant paid. It's going to not only dedicate it to a particular node, but the policy is also going to make sure that my priority class paid is added or mutated or injected into the pod, using which my scheduler is going to give more attention to my pod, which is paid, compared to that of the free tier. Okay, so just summing it up, Jim, over to you.
All right.
Let me just share.
Yeah,
stop sharing my screen.
Thank you. So certainly a lot of use cases that we saw over there, right? So just to kind of summarize and look of some of the things we went through. So as you saw, Kyverno makes it very simple to secure, automate, through mutate, generate policies, whether it's multi-tenancy or other use cases you're addressing. Kyverno can also, in addition to admission controls, we also looked at the background scanning through reports and the CLI. And it's something, Kyverno, like we are, certainly in terms of the maturity and where it's at, it's in production already with several customers, several community members. So, and Kyverno is now from sandbox, we graduated into incubation, right? So definitely check it out if you haven't done so already. Feel free to join any of our Slack channels. Come say hello over there. Most of the maintainers are on the Slack channels as well. And we also have, weekly as well as weekly contributor meetings, and then monthly, end user meetings, right? So would love to see everybody join us for our upcoming session. There's also a certification out there. So if you're interested in that, feel free to take a look. All right, so I know we just have a minute left, so sorry we took up too much time, but there's plenty to show, and hopefully this was valuable to everybody.
Absolutely. It was mesmerizing, a terrific presentation. I really enjoyed that. So thank you so much, Jim. Thank you so much, Dolis. I really appreciated that. And we got some questions from the chat. And the first one is a little question for the creators. In the docs here, and there is a link, we can see that Kyverno is compatible with Kubernetes 1.23 at maximum. So Kyverno 1.8 will be compatible with Kubernetes 1.24 and 25, or the docs is not updated and Kyverno is already compatible with the latest Kubernetes. Thanks.
So you can, yeah, so good question. And yes, so Kyverno and the docs are reflecting what we have tested with. So when 1.7 was released, it was with 123, but we do test the main release right now, which will be 1.8, is being tested with 124. 125 is still pretty new, so we will support 124 with Kyverno 1.8.
Oh, that's great. And I got also a question from my side, and Dolis was showing that if you issue kubectl get cluster policy, there was a ready column. So the question is, what's that ready column?
So it means that Kyverno is ready to process that policy, right? Because it takes a little bit of time when you're running multiple replicas to cache that policy, to kind of go through it and make sure that it can be applied. So it's just giving an indication that the policy will now be applied.
Okay, thank you so much. I really love this kind of internals. That's the question. That's the reason why I asked that. Anyway, also the people that is still in the chat in this webinar, if you would like to unmute yourself to ask the question directly, don't be shy. Anyway, we got also another question. So Jim, can you explain a little more about Open API specification and leveraging owner references to enforce policies that you mentioned in the starting? Are we using the same Open API specification as Kubernetes?
Yes. So it's doing a lookup from the API server where Kyverno is running. And what Kyverno does when it first gets installed is it will go ahead and cache all the CRDs, all of the internal resources, because different versions of Kubernetes, even for built-in objects, they might change, right? And then when you are applying a policy, it will use that to know whether the policy is valid, or like if you got a path or something wrong in the policy, it will tell you that, hey, your policy doesn't match the schema, right? So that sort of detail is only possible if it can see the CRDs or the Open API spec. And yeah, the other question was on owner references, right? So Kyverno takes advantage of that also, because if you have pods created by deployments, it knows that that pod was created by that deployment and can see if the policy was applied at the deployment level or not. It will still rerun some checks on the pod, but it uses this type of information to make some decisions.
Absolutely interesting. I really love Kyverno, because what I said also at the beginning, what's really great is that it's totally compatible, totally native to Kubernetes. So it's something that it's filling the gap regarding policy management. So really awesome. And let's wait for further questions, but keep in mind that all the people, if you love this webinar, please let us know, because Kyverno is, I'd say it's not a product. Well, I don't want to offend anyone, but it looks like a framework to build a lot of stuff. So it will be great also, from my perspective, to see more content like this in our community, maybe showing how can we enforce multi-tenancy with the multi-cluster management or something like that. So just to say that, let us know on Meetup, on Twitter, on LinkedIn, or whenever you want, so we can reach out to Jim and Dolis in order to ask further content for our webinar.
Absolutely.
Okay, I guess we are done. So let's wrap up the meeting here. And thank you so much, Dolis, again. Thank you so much, Jim, also for the time that you provided us. And it has been a pleasure. Thank you so much.
Really, thank you very much, Dolis, Jim. It's been a pleasure. We really hope to make this again. First time of many to come. And guys, if you loved this kind of content, please let us know in the social, and we will try to deliver you our great content.
Yeah. Thank you so much. Bye-bye. Cheers.
Bye. Ciao e buona serata. Ciao.
Have a nice day.